More line segments and points of concurrency. Welcome to Lesson 5.3 of Chapter 5 in the Pearson Geometry video series. The first new line segment is the altitude, which is another word that means height. In fact, when describing how high a plane is flying, the pilot will say the altitude the plane is flying. It's drawn from the vertex straight down. The point of intersection from the three altitudes in a triangle is the orthocenter. The last line segment is the median. The median is vertex to midpoint, and the centroid is the intersection point of the three medians. Theorem 5.7 sets up a special property unique to medians and centroids. It says the medians are concurrent at the centroid, which is 2/3 the distance from the vertex. So let's take a look at the diagram down below the theorem. Here is our centroid right here. You'll notice that from C to F, which is our median, this top part, the part that goes to the vertex, is a little bit bigger. Actually, it's twice as big. So if we split up the distance from the vertex to the side, we end up with 1/3 of the segment going to the side, 2/3 of the segment going to the vertex. The same thing is true right here. 1/3 and 2/3. And the last one, 1/3 and 2/3. So if I have this segment, I can double it to get this one. If I have this segment, I can take half of it to get this one. And if I have the whole segment, I can divide it by 3 to get the smaller one, and then double it to get the bigger one. So let's take a look at example 1. In example 1, we are asked to find the length of JN. That's the entire distance of the median. So we know that the longer section that goes to the vertex is 18. So if we take half of that, then we're going to find that the smaller section is equal to 9. 9 is 1/3 of the total median, and 18 is 2/3 of the total median. If we add those together, 18 plus 9 is going to equal 27, so JN is equal to 27. For now, we're not going to pay any attention to these triangles. We're going to come back to those when we do our constructions. But it is important that you know that the centroid is the triangle center of gravity. And what that means is that if you have a triangle of any shape and you find the centroid where the medians cross, it will balance on that centroid. That is the center of gravity. Okay, go ahead and flip this over. Theorem 5.6 has to do with the orthocenter. The orthocenter is where the lines that contain the altitudes of the triangle are concurrent. Again, we're going to ignore these for now, but let's take a look at the diagram down here. So right here I have my three altitudes. Start at the vertex and go straight down. Remember that altitude is another name for height. So I have if you turn the triangle onto each base, then the altitude is going to be the height of the triangle when it's sitting on that base. Okay, let's spin it back around. So each of these are concurrent, or that is, they intersect at the orthocenter. Okay, this one, unlike the other three line segments that we've done, medians and angle bisectors and perpendicular bisectors, this one has no special properties beyond what you see right here. So let's go ahead. This part we are going to do in class. We will figure that out in class tomorrow. But for now, let's take a look at the problems down below. And this has to do with medians. And you know that this has to do with medians because the median goes from the midpoint, and this is a midpoint, to the vertex. That's how you know what you're looking at. Okay, so we have 3 medians in this triangle, and they intersect at a point which is going to be our centroid. Now, if we have a centroid, that means that each of these medians is divided up in 2/3. So from here to here is 1/3, from here to here is 2/3. So we're looking at AF, and it's going to be easier. The centroid is M. Okay, so that right there is M. So if we're looking at EM, EM is equal to 8. And right here we have FM, and FM is equal to 9. And then finally right here we have MB, and that's going to be equal to 24. Sometimes it's hard to tell where those numbers actually go. Okay, so we want to find AF. So AF is this entire median. Of this median, we know that the 1/3, the smaller part, is 9. So that means that the larger part is going to be double that. So this is going to be 9 plus 18, which equals 27. So that means that AF is equal to 27. Okay, now let's look at CE. For CE, we know that the smaller part is 8. And if we add the larger part, which is going to be double, that would be 16. And so we end up with 24. So CE is equal to 24. Finally, we have BD. Now we have the longer side. And to that, we're going to add the 1/3. So if we have 2/3 and this is 1/3, we can take half. So that's going to be 24 plus 12, which is equal to 36. So the entire length of the median is 36. Okay, now let's take a look at some pieces and parts. So we have CM. CM is the longer part. If we have the shorter part, which is 8, then we can double it. So CM is going to be 16. DM is also the shorter part. We know that the longer part is 24, so we can take half, and that's going to be 12. Finally, we have AM. AM is the longer part. The shorter part is 9, so we can double it, and we get 18. These are the properties that you're going to be working with centroids. That's it for now. See you later.